In item 3 of the first exam, in statics, we're asked to find the moment with respect to point D of the 300 Newton force applied here at A. And since the 300 Newton force at A is at some relatively arbitrary angle, in this case 25 degrees, it's a lot easier to figure out how to break apart this force into its resultant x and y components, because the dimensions are provided to us in that direct fashion. And so that'll make the work much easier to do this calculation. So in part A, we can find the moment about D from the force at A. Well, we need to take some sort of direction as positive. I'm going to guess that the AX force, because it's larger and has a large moment arm, is going to overwhelm the opposite effect. And so I'm going to take counterclockwise as positive in that equation. So I'll have AX, which will be equal to 300 times cosine of 25 degrees. That's the force component. And then its moment arm, that perpendicular distance between it and the point of interest, is 200 millimeters, or 0.2 meters. So units here are newtons times meters. And then the AY component is going in the opposite direction. Its magnitude is 300 times sine of 25 degrees. Its moment arm is now 0.1 meters. And then you add those two up and you get then a value of a plus 41.699 Newton meters. And then the plus indicates to us that we are going to have a net direction that is counterclockwise. And then using our rules here for rounding in statics, then we go to 3 significant digits, and that will be a counterclockwise total rotation. Now that's one way that you could do it. Now if you didn't want to do that, instead you wanted to maintain using the total magnitude of the force and not break it apart, then you're left with trying to figure out what that perpendicular distance is going to be between the line of action of the force and point D. It's not going to be given to you directly. So what I see when I look at this is that if I only knew some right triangle kinds of things, such as what if I were to know that distance right there? Well, I do know that this angle is 25 degrees. I don't know this one over here, but I do know by Pythagorean theorem, 100 squared plus 200 squared, take the square root of that, I'll get my hypotenuse. And that will be 100 times square root of 5 for the hypotenuse. Right? And if I then do arctangent 100 over 200, I can find out that this angle right there is going to be 26.565 degrees. Again, that's from arctan of 100 over 200. And I'm going to leave a lot of those digits in there because it's an intermediate calc and that might be useful to do. That'll leave us then a interior angle here of 38.43 degrees, 90 minus the 25 minus the 25.65, and that will allow us then to figure out what this perpendicular distance is. And so that will be sine of 38.43 times the 100 root 5 and that will work out to be 138.999 repeating, so that'll be 139 millimeters. If you do that, then you'll find out, and it's clear that this is a clockwise rotation, you would get 300 times 0.139 meters, that's a Newton there, and that will give you the same number, 41.699. And so our answer is still the 41.7.